Hello, everyone. My name is Elisa Baum, and I am Percona's Director of Product Marketing. We'll begin in just a moment, but first I'd like to begin a bit of house cleaning. First, can you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me? Okay, thank you very much. I see lots and lots of hands. Next, during this webinar, you will be on mute. Should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible, and those that aren't addressed will be answered in a follow-up blog entry on Percona's MySQL performance blog. In addition, a recording of this webinar will be made, and I will send it out to everybody within 48 hours. I would like to thank you for attending today's webinar called 5 Proactive Measures to Minimize MySQL Downtime. This is presented by Percona's Senior Consultant, Fernando Ipar. And with that said, I'd like to turn the floor over to Fernando. Fernando, you have the floor.
Thank you. Thanks a lot, Elisa. Hello, everyone. Thank you for attending this Percona webinar. I hope you find it useful. And at the end of the deck, you'll find my contact information in case you have any follow-up questions that we cannot address today, even though I will be doing the follow-up blog post. But anything you can come up with even at a later time. So let me start with a little bit of information about myself. I've been a MySQL user since about 2000. Version 3.23, and I've been with Percona since 2009. So specifically for this talk, over the last couple of years, maybe a bit more, most of my work has involved consulting services, attending customers' emergencies, and performing data recovery work. And so I've taken a lot of that and put it into the information that I'll be sharing with you today. So specifically about the talk, this is completely based on my analysis of emergency cases from the last 12 months, maybe a little bit more. I'll review the failures or the problems that caused the emergencies. And I came up with these 5 measures that, if you take them, it can help you avoid or minimize the downtime usually associated with this kind of failures. So as we go through them, you may think that they're obvious, but my experience tells me that a lot of people out there really don't implement them, or at least not all of them, or in a good way. So let's start with some basic considerations about disaster. What about disaster and what it has to do with downtime in MySQL? And the first thing is that any friendly dinosaur will let you know disaster is just bound to happen. It's only a matter of when, but not if. So with that in mind, let's go and review everything. Of the cases I'll review by preparing this presentation, almost 60% of them would have been avoided or at least mitigated if these measures had been in place. And not all of them, by the way. Not the 5 measures, just some of them would have helped over almost 60% of the cases. So that's a lot. And by the way, when the graphic says unavoidable there, I did not mean that it's just a problem that could not have been avoided anyway, just that it would not have been avoided even with the 5 measures I mentioned today in place. Okay, so let's get started. So first things first, you may think that keeping backups is something obvious, but I have a very long list of data recovery cases that can prove that wrong. So some people think that they have a backup when in fact they have redundancy. Anything that faithfully copies your data live will also faithfully copy lots of failures that end up causing downtime. Just imagine something like an accidental drop table or a delete. Those are usually most common cases of data recovery work that I've been involved in. Or file system corruption. So redundancy helps, and in fact it's one of the measures we'll be talking about today, but it's definitely no replacement for a proper backup. So with that settled, there are a few choices to back up a MySQL database. Regardless of what you choose, the most important thing to consider is that a database server is a very special case for backup software. You may be using something like Bacula or Zamanda or any other backup software up there, and that is okay. I'm working with a lot of customers that do, but you need to bear in mind that databases need to be backed up in a consistent case. It's not just like, backing up the files in the web application, things like that. And so in MySQL's world, where we have these architectures supporting multiple storage engines, doing a consistent backup has a different meaning for different engines. So in MyISAM's case, it basically means locking the tables while you copy them. And in InnoDB, it can mean extra backup, in which case you have almost no locking or no locking at all, depending on the type of backup that you choose. Or using single transaction with MySQL dump, which also would not be blocking anything, only if you are InnoDB completely. So regardless of the engine, if you use, for example, a file system snapshot, you may be doing a backup with little locking if you have enough space. So in comparison to what I mentioned before about redundancy, I would consider a backup anything that provides a faithful and consistent, emphasis on both, copy of your data at any specific point in time. So the main difference is that the backups are not live. And that way, by not being live, they will protect you for things like a drop table or file system corruption. So there are some things to consider when you choose the right MySQL backup solution for your case. And that will be a whole webinar on its own. But roughly, you can classify them, whether they do a lot of locking or not locking at all, how compatible the backup is across versions, and how much time it takes to backup or restore. So let's go through them. In terms of production impact, usually something like MySQL dump is not very good on a production server. People that do it tend to wait until off hours, if possible, to do it. Even when you have full InnoDB data set and you're using single transaction, there's still the impact of having this huge long-running transaction open, which will eventually can lead to a growth in history length, a lot of versions for InnoDB's MVCC system, and so in general it can have a lot of impact on a loaded server. So a lot of people do using MySQL dump for backups, either do them off hours or running on a slave. The other thing is the purpose. If you want to do a backup just for the purpose of preventing or protecting against failure, which is like the most common use case, any solution will work. If you need to clone a server, well, it's similar, though perhaps if you do not have a slave and you need to clone a master, you would be better suited by some of the non-locking options like extra backup. And if you want to do the backup for an upgrade to a different version, when in some cases the manual actually recommends MySQL dump as the only course of action in that case. So you just need to, assess your options. In terms of data set size, basically what I can say is that something like a MySQL dump does not scale well, mostly for restore time. I mean, backup time is usually kind of linearly scaling. I mean, as your data set grows, it will take longer, but roughly in a good proportion. But it's not the same with the restore time. It could take orders of magnitude more in that case. So if you have a very large data set, I would definitely always choose to go for a binary kind of backup, either extra backup or a file system snapshot, or even just if you can afford it and you have a replica, just shutting down MySQL and just copying the files. Any of those will definitely give you a much faster restore time. Okay, if there's only one thing that you can take away from this presentation, then let it be that an untested backup is as good as no backup at all. Maybe that's it's not that bad, but potentially it may be because it can give you a false sense of security and you may end up being worse. And so testing involves restoring. You actually have to go ahead and try to restore. I'm sorry, I got a message about moving the mouse pointer. I hope it's better this way. In the cases that I work with, a lot of customers take this opportunity databases with actual production data. Depending on your line of business, you may have to change some of the data to protect privacy or save credit card information. And it's still easy to test the restore, do some scrubbing procedure there, and then moving on that to staging or development. And it's one of the ways to test it. Another way is to restore to a replica, which can be an actual replica that's part of production for you, or it can be like a throwaway instance, even a virtual machine, and then run pivot table checksum and see if the data actually matches up, if you're doing it right in a way. If you have some big data, and in this case, not trying to use any buzzwords, but I would consider big data anything, anytime that your whole data set does not fill on a single server, I will call that big data. Then you will have to get a bit creative with the process. Normally, what I recommend is that you, for example, you can restore each shard in terms to a single server to, so that you don't have to have lots of nodes just for the purpose of testing backups. And you can use the same procedure, PD table checksum, which in an individual shard. And you can even just tell PD table checksums to only run through a subset of the data. And if you're careful in picking up the subset, for example, making sure you pick the data that should have changed more recently or something like that, you will still be a lot better than not testing your backup at all. Normally, when people have this kind of size, I mean, when they have many, many nodes and the database, logical database that does not fit on a single physical server, the backup is really just a last resort. I mean, we typically use replicas as a fallback, and then something that happens, you can promote a replica. But should all of them go down, or maybe the job table problem that I mentioned before, well, then you have to resort to a backup in that case. Well, in line with this is redundancy, which we already discussed a little bit. This basically amounts to avoiding single points of failure. All the things that I mentioned as not being a backup would provide you redundancy. So, for example, a replica. Sometimes you can have a replica that gives you a mix of some redundancy and also some like a poor man's backup if you, for example, delay replication. So say if you force a replica to stay 30 minutes, 1 hour, or whatever is the number for you behind, it will still protect you against most things like an accidental drop table, accidental delete, and still give you, a reasonable amount of redundancy. But ideally, for redundancy's sake, you would like to have a normal slate. You still need to bear in mind that MySQL, as it is out of the box, and I'm not going to be discussing NDB cluster or Galera today, it's just not in sync. So replicas are not guaranteed to be in sync with the master at any point in time. Even if more recent versions provide some of that, it's still not nearly close to call it like synchronous replication. So RAID is another alternative. I guess the difference is in the replicas you're just making the whole host redundant, whereas in the RAID you're making the actual storage redundant. And which way you prefer, or maybe you prefer both, depends on your budgets and your needs. RAID have another benefits besides just redundancy. I mean, it can definitely improve performance, so you may be having it for a different reason and still keep the replicas on to have host level redundancy. You can also choose to have a shared device, either a SAN or something like DRVD. Bear in mind that some of the failures will not be covered by this. For example, if you experience a file system corruption or maybe InnoDB corruption because you hit a bug, then any instance reading off that storage, shared storage, will hit the same problem. Normally this kind of setups, it's with a active node and a passive standby because you cannot mount the dir directory on multiple machines. And so this type of corruption, mostly failures, are not protected by this. But a lot of others are, and so it is still a good way to achieve redundancy. So basically, any faithful and live to make a difference with the backup copy of the data, that would give you redundancy. So depending on how it's set up, redundancy may still mean that in some failure scenarios your capacity would drop. Not everybody can afford to have enough spare drives and servers and everything so that you can basically hit a problem and still be running at full capacity. It's just like a car. When you hit a flat tire, normally you have one spare. If you hit two, you need to call somebody else. So in this case, it's very good if you can support a degraded mode. That could amount to falling back to static content, disabling writes, for example. Maybe you lost your master, but you have some replicas, and at least if you can just suspend writes but still keep serving content, it's better than nothing. And I'm highlighting here modularity and configurability because I think without those it's very difficult to support a degraded mode in my experience. If you already have those in place, then you can get creative. So to give you some concrete real-life examples, I have worked with customers with very high traffic sites that, if needed, can block access to people in certain geographical areas using some specific user agents or visiting certain portions of the site. So for example, imagine an online news aggregator, and suddenly you hit a very hot news, special day, something like a major event, and you may have to disable comments on the news article so that you can still serve it, even if people cannot add to the discussion. Or you may be able to throttle comments. It's better if some random user every now and then gets something like, fail to save comment, please try again later message, than if they just cannot load the web page at all. So this thing is something you need to build into your application from start. And even if you don't invest in development and the fully degraded mode support, if you develop the application in a way that is properly modularized and configurable, then you will be in a much better position to add this in the future. So an excellent way to avoid surprises is to always test changes before making them in production. That's why I'm mentioning this as the third measure to be using. And let's start by discussing the upgrade process. There's always some level of risk involved in upgrading MySQL, changes in syntax, optimizations, or features that, those are some of the things that can change. And so you can always just stop MySQL, upgrade, start, and hope for the best. And sometimes you may even be forced to do it. Like I personally resolved more than a few emergency cases where MySQL was overloaded due to permanent increase in traffic, meaning that traffic just went up and it's just the business changed. There's no way to get traffic to go down. And they were running old versions, like 5.0, that does not scale well in terms of concurrency. And, the only course of action there to resolve was to upgrade to a more recent version. But normally, at Percona, the recommended upgrade process includes a minimum of testing. And Percona Toolkit included a couple of tools to do it. PD upgrade was specifically designed with the upgrade choices in mind. And even though PD table checksum is normally associated with another set of problems, it also comes in handy for safe upgrade. So let's assume you have a single production server, say on 5.1, some 5.1 version, and you want to upgrade that to 5.5. Sorry, I'm going back. Okay, so what we can do is we can set up a new server with the target version and then get it to replicate up the master host. Depending on how the master is set up, this may involve some downtime. I'm not going to go into all the details because it's not what the presentation is about. But any of the methods discussed when we talk about backups can be used here. So once this is done, you have host A, the production server running 5.1, and host B, the target host running 5.5. So once the flow of replication is running fine and there's no lag, you can start running periodic runs of PD table checksum. There is a sample invocation there on the slide. And basically what this will let you know is find out if there are any incompatibilities between the two versions that may cause replication to break, if there are any changes in data types or in default behavior. Sometimes replication may even break. For example, when a specific query that worked fine on a previous version stopped working on a newer one. And so really, imagine it's much better if you catch this without the stress of being live. I mean, you just see the replication breaks on host B, which is not production, not visible to the world. You can take your time, talk to developers, and see where in the application it should have to be changed, change it. If needed, fix or even rebuild host B and do the whole process again. Then if you just find out, when you just upgraded host A from 5.1 to 5.5 and suddenly maybe the same moment or a few days later, something breaks, some writes are not able to finish and just no way to work around it. So that's one of the reasons why it's good. It's also important because if you are, you're doing a lot of checking to make sure the replication, the flow works fine, you can then even just upgrade with minimal downtime by setting up something like a virtual IP on host A, pointing your application to it or your applications. And when you're done and you're happy with the test results, you can just, migrate to host B, be done with it, and basically the amount of downtime involved in this upgrade is just the amount of time needed to move the IP from one host to the other. So in general, if you can afford to have a spare server, it's a very good way to upgrade. Another thing related to this is using PT upgrade. PT upgrade was designed to take a capture list of queries that you can take on, in this case, in host A, either from the slow query log or using something like TCP dump. And you get the list of queries and you feed that to PD upgrade and tell it to, or maybe even more hosts to run it to. And it will run the queries in the file and it will let you know any differences in results, in response time, errors, and warnings. And so this is very good to catch things like optimization regressions, queries that finish very quickly on one version and start to take longer on a newer one. That can also happen because perhaps you are optimizing your application for to work around the defect on the 5.1 or whatever version you had as a source, and this was resolved on a newer version, and so your workaround does not work quite well anymore. Warnings could be even errors when MySQL has been getting more strict over time. It used to be the case that you could insert something like the 48th of February of whatever year, and it would work even though the data actually written into the database would not make sense. By default, more recent versions are a bit more strict, and so you want to catch this again without the stress of being live. So the more you can do these two cyclic processes, iterate one and again until you feel confident enough that you have covered most of your workflow and your application code path, it's the safest way to go ahead and do the upgrade. So beside upgrades, it is also recommended to test application changes. This allows you to avoid surprises when deploying new features. If you're a very agile company with short release cycles, it may not be feasible to do this all the time, but I would still encourage you to try this at least before significant changes. I mean significant here either because they change a lot of code or because they change a heavily used part of the application. So for example, I worked a lot with an online retailer, and their release changes every week, sometimes twice a week or more. And so they could not really test everything. At last, they did the basic testing, but not like a load test for every case. But whenever they were preparing for the major deal, for which a lot of traffic and interest was expected, any code changes were tested this way. And this decision helped them catch bottlenecks ahead of time, and then basically just make it nicely past the storm of actual traffic. So for this to work out, though, there's the two things that I highlighted there. It's very important to test a realistic workload and a realistic data set size. Let me explain a bit why I say this is so. Let's assume we're going to be deploying something that makes use of the table shown here. Please excuse the simple example, but all the good ones I will have are confidential from customers. And so the query looks harmless enough, but perhaps some readers with experience in high-low MySQL environments will have spotted the problem already. I have highlighted rank since the query is ordering by that column, which is not indexed on the table. And so how would this perform? The answer, as usual, is it depends. You can take a look at this graph. This is the result of me running MySQL slab with that schema and that query at the level of concurrency indicated below on the x-axis, and then you have the result time. Now the dark blue bar shows the query response time as it evolves for the schema without the key. And the light blue bar is, well, it's barely visible there, but it's basically when you do have the key there. So you can notice how actually even the bad, so-called bad query, actually is the bad schema for the query. It performs acceptably at low loads. It's still worse than the good schema, but you can live with it. So imagine you have a team of QA people testing this, and you probably, unless you're a very big place, you don't have hundreds of them. So you may have, even 5 people at the same time, they will probably not hit the query at the same time. But let's imagine, for the sake of argument, that they do. The response time will still be probably acceptable, and so this may make it past them. And so eventually then you release this, and if you normally have, say, 100 users, well, you can see from the graph, just 50 of them hitting the same code path in the application will make this perform really poorly. And if you go above that, it just probably becomes unbearable. On top of that, not only are people getting very bad response time, this snowballs into what normally it's called like a global stall, when everything else starts to block up because the server is busy doing something a lot. And so even quote-unquote good queries start to turn bad when something like this happens. So the query here is isolated, but if with others with access in the same table and all that, it will be even worse. So the solution is very simple. In this case, you just need to add an index to the table. But just imagine having to do that on the live server, especially on one that is already overloaded. That's definitely not a nice place to be. So this is why I put the emphasis on testing with realistic, both data set size and query size. In this case, In the query that we looked here in the example, the problem basically is because of the missing index, it's going to be doing a temporary table to do the sort on that column, and that works okay on low concurrency, but as you add a lot of threads, concurrent threads to the mix, it's just not manageable. It's just, no matter how big your server is, you will eventually going to be running out of memory for doing that sort and things like that. And so it's a simple problem with a simple solution, but if you don't do proper testing before deploying, you're likely to find out when you get hit by this in production. So finally, I have a couple of suggestions involving having a rollback plan and then linking first to the code path. The thing about the rollback is needed because sometimes even the best testing will meet the bad queries, or the queries are not really bad, but you misestimated the workload. Say you have normally 50 concurrent users, so you went ahead and tested with 150, and you narrowed down the bottlenecks and fixed the schema and the queries, and then somehow you end up on Reddit or Slashdot or whatever, and you have an order of magnitude more users. It's still going to hurt you. And so in this case, the ability to roll back the change that is behind the problems, it would be very useful. In line with this is what we mentioned before in redundancy, having a degraded mode. It can also be very useful to put up through this, especially hot period. And the second suggestion, the comments there, is very useful once you identify a query as being the root cause of a performance problem. Basically, this saves a big chunk of the work of that post-investigation, which is finding out in the application or applications that may be accessing the database where this query is being issued. Just imagine, it's much better to say, there is a major issue in the code that lists items in the shopping cart than just saying, this query is killing the whole site. Who knows, which part of the application runs it. So I have seen this used a lot in customers in the past. For some people using the query cache, this was a problem because of the common, but Percona server has a feature to just ignore that and basically remove the comments for the query cache, and I believe upstream MySQL has already incorporated that, or at least developed a similar feature in more recent versions. So really, I think there are probably none, or at least very little downsides to this, and the advantage is very good. I have personally experienced a lot. Fourth measure to discuss is safe replication. And so what do I mean by safe? Like, shouldn't it be safe out of the box? Well, let's go ahead and see. Since 5.1, MySQL supports two formats for the binary log. This is statement, which has been there since the beginning, and row-based. Normally, these are referred to as SBR or RPR. So even though my personal opinion is that statement is widely deployed, it's been there, like I said, since the beginning. I guess, if I don't recall incorrectly, since about version 3.23. And it's probably one of the reasons why MySQL hit it so big, because it had support for replication very early on, which was unusual for an open source database server. At the same time, again, my personal opinion is that it's fragile by design. It's just not realistic to actually run the same query on multiple servers and expect them to yield the same results. So even though a lot of context information is set by the replication thread, and a lot of bugs have been worked out, I always get the feeling that there's still some surprises waiting there. On top of that, definitely some things are unsafe with statement-based, which are not a problem with role-based. For example, somebody pointing a replica to the bad coordinates. This can happen, for example, if you have a crash on a slave server and you're not using crash save replication. It's bound, it's very possible, unless the whole system was idle, that the server will come back pointing to the past. It will have coordinates to the master that are in the past. In this case, it will be replaying statements, and even though some of them will just fail, say an insert will give you duplicate key errors, an update won't. And so imagine you have an update statement that is, say, incrementing a counter. With statement base, as many times as you replay the statement, it's going to keep increasing the counter. So definitely not safe, and a very easy way to get into what's called like silent data drift between two nodes. One of the many reasons why replication may go wrong. So for some time now, probably at least for 3 years already, I've been normally recommending role-based unless you have a strong, and documented reason to stick to the statement. And with that in mind, the most important thing is to make sure that you have either a primary or a unique key for every table that you're replicating, or at least for every big table. Now, the reason is that unlike in statement where MySQL goes and actually runs the query, in row-based it just sends a before and after image of the row. I believe, though I'm not sure by heart, that 5.5 and earlier versions, so basically 5.1 and 5.5 here, they include the whole copy of the row, all the data from all the columns before and after the change. Whereas in 5.6, there is an option to enable this to only send the differences. But in either case, the first thing replication has to do once it's applying an event in row-based format is to locate the row that needs to be changed. And if you do not have a primary unique key, it's going to be basically doing a table scan for every event. So you can do the math yourself. Just imagine your tables. Imagine how many rows you have and how many update events you get per second, whatever. And if you don't have these proper indexes, which I have seen sometimes, a lot of people are running without primary keys. A lot of the times, because they're using the schemas that came with some prepackaged software, it's going to be painful for row-based. You will notice this because you will be basically lagging a lot. The slave will be lagging a lot. And if you look at the reason for the lag, it's because it's going to be spending a lot of time running single events. Now, row-based replication is a little bit trickier to debug than statement because you don't actually see the statement being executed because it's not a statement. But you can go and use MySQL bin log on the relay log or the bin log. And if you use the option to make it verbose, it will try to reconstruct the statement from the data. So at least it will be readable to you, and you will be able to identify the query as it would be if it was statement. Another safety measure in terms of replication is to monitor replica lag. I mentioned PT Harvard here because it's probably the most accurate way to measure that. But in most cases, just checking seconds behind master is a good enough gauge. And the reason lag is important is at least twofold, probably more. But the two biggest reasons are, first, as the more a replica lags, the less is going to be good for you in terms of redundancy. If the master goes down and your replica was a lot in the past, you may be missing some events. It's not as simple as that because basically what can happen is that the SQL thread is lagging behind while the IO thread is up to date. So in that case, you will have higher than normal, higher than needed downtime, but you will lose almost no data because eventually, the replica would finish catching up. But you still need to check that. And the other reason is that, a very common use case for replication in MySQL is to scale out reads. And if you scale out reads, but you have replicas that are lagging, your application is going to end up reading stale data, or even, is going to fail or missing data. Suppose you are creating something on the master, and then you expect to be able to read from any replica in the future. And if replicas are like 30 minutes or more behind, and the user sends two queries with just a few seconds or maybe a few minutes difference, the read query may fail. And so for those two reasons, and there probably are many more that you can come up with, it's important to monitor lag. Another measure is to avoid huge transactions on the master. I refer to transactions because I typically use InnoDB, and that's what we recommend, unless you have a very good reason otherwise. But the same would apply to MyISAM in terms of not transactions, but huge statements. So here, basically, what I mean are things like, load data in file, or a major update or delete, like deleting from a table, archiving processes. And the reason is that, it's all boils down to the single-threaded nature of MySQL replication. I'm assuming that all of you know about that, but just in case, I'll take 1 minute, because I said it's single-threaded, and then I mentioned 2 threads. Replication works on slaves by having an IO thread. This connects to the master and fetches binary logs, writes them locally as relay logs, and then the SQL thread just reads these events or statements, depending on the format, from the relay logs and applies them locally. So that's why it has 2 threads. But the SQL thread is just single-threaded. So while on the master, multiple queries changing data may be running concurrently, depending basically on the concurrency of the application, they will be serialized on the slave. And so you can easily see that, say, a a massive delete from a huge table that takes, I don't know, 10 minutes, 1 hour, it will take the same in both nodes, but the difference is that while the master can keep running other transactions on the same server, as long as the same rows that are actually involved, it's not the same on the slave. The slave is going to have to wait until that event finishes before it can continue processing other events. And so there's no way to work around it. Like I said, not even with the parallel replication that is built into later MySQL versions, because basically that is per schema. And probably not even with, I don't know that much about NDB, but definitely not with Galera either in this case. So in order to keep replica lag low, you definitely want to avoid huge data changes. The way to do is, well, basically, it's easier said than done. But for example, for deletes, you can use, there's a tool called PT Archive that lets you purge data from tables or move it to different tables or to a file in a controlled manner. By default, it will do it by deleting or moving one row at a time. And it can even, watch lag if you want, and you can do it. So it's reasonably safe to do this in your replication environment. In the case of something like low data in file, you can try with something like, for example, there is a tool called PT FIFO split, but basically you can give it a file as an argument, and it will be, or just read from a FIFO, and it will just split it in chunks of n lines. This is not completely safe always. I know there is an open back if you have events that may be multiple rows, so I think that may be the case if you have very large, say, blobs or binary fields. But it may work for you. If that's not the case, I would just recommend trying to chunk yourself the source file so that any given chunk is not very big, so that replication lags behind. Also, without those tools, and I work with many customers that just implement these things themselves in the application. And the key to everything is just monitoring the lag. You must have a way, whenever you do something that may be write intensive and replication is involved, you need to be monitoring replica lag. And here I do not mean something like Nagios. I mean monitoring from the application. In the customers I have worked with, they have the script to be doing applying changes or backloading data from another instance, things like that. And they are constantly, they do it in chunks in a loop. And between each iteration of the loop, they go ahead and check lag. And if lag is beyond a certain threshold, they just stop until it goes back to an acceptable value. Final considerations here, again, assuming NDB or Galera are not involved, because I'm not covering those today, is to set the passive nodes at read-only. In fact, normally I go as far as to recommend setting up all MySQL nodes in a replication topology as read-only, even on MyCNF. That way, when they come up, you're guaranteed that they have the flag set on, and you can then change it dynamically when you promote the node to master. Now, in order for that to work, you need to reserve the super privilege for admin accounts, root or any other account that actually needs it. The reason is that when the read-only flag is set, MySQL will only let the replication thread and users with the super privilege to change data on the server. So this may sound obvious again, but I have seen a lot of cases where applications are running in production using the root user to connect to MySQL. So that's not a good idea. And as a side note, the last thing is a bad idea because of this. It lets you write to any node, and also because MySQL keeps an extra connection beyond max connections for users with a super privilege. The idea behind this is that if a server becomes so overloaded that it runs out of connections, a sysadmin can still log the application uses root, you lost that extra connection. So there's no way for you to know what's going on unless you actually stop the application or shut down some nodes if you have multiple app server nodes. So in general, it's always a good idea to be very conservative about privileges, and more so about the super privilege in MySQL. Now, finally here, this is actually the last one on this section, is periodic runs of PD table checksum. Now, even if you follow all the advice that I've given here for replication, you may still end up with data differences. It may be because somebody managed to somehow write data to a slave. In my experience, writing data to slaves is the #1 cause of replication-related downtime. But it may also be because you hit a bug. It happens. And so the only way to make sure, my message is, do not assume that replicas are in sync. Just go ahead and actively check them. And pivot-table checksum was designed for this. By the way, do not confuse this with the replication checksums that are in, I believe, 5.6 of MySQL, and they're not related. Pivot-table checksum basically, takes the master, runs some checksum queries, and then runs the same on the slave using statement-based replication by design, precisely because, as I said, statement-based may yield different results on two nodes. And in this case, it's using this, shall I say, defect in design to its own benefit, because if it yields a different result, it means that there's different data in the servers. And so normally what I have doing with customers, I set this up in cron. I set up a cron job to run pivot-table checksum. It's normally safe to run live. It has a lot of self-throttling mechanisms, so you can run it in production. I would normally prefer to, if run in an active time, to have somebody monitoring things. Otherwise, to run it automatically, but during low traffic time. But that's just because I've learned to be overly conservative because of my job. But it really is pretty safe to use. And so we've reached the final measure, which is to monitor MySQL servers. I'm also mentioning training here, as I believe the two are closely related, and in fact, some of the industry solutions tie the two concepts together. So let's start with mentioning that Percona has developed a set of monitoring plugins and graphic templates for Nagios and Cacti. If you're using either of those tools for monitoring and trending, I highly recommend installing our plugins. If you're using Percona Server, even more so, because the plugins make good use of the extra diagnostics information that Percona Server exposes. There are other alternatives I'm mentioning there. Well, my personal experience, for what it's worth, is that mostly, other than Nagios, which is what I have seen deployed most, I have seen Savix and Xenos. I have not had a lot of experience with running myself, but that's mostly anecdotal evidence. And the reason why you need this, it should be obvious to most people, but again, I have worked in a lot of emergencies and people did not have anything of this in place. It helps you take care, minimize or even avoid simple, silly things, but really, once you figure out that you had downtime because of that, it's very frustrating running out of disk space, something so simple and easy to monitor, yet a lot of the times I have seen MySQL being down, and when you connect, it's just because of that. Degraded hour, this is related to the redundancy part. It's fine if you're running a RAID. Suppose you just follow that advice and set up a RAID card. You want to know if it's running in degraded mode. You want to know if, for example, the battery in the write cache is going through a learning cycle, things like that. Max connections, what I'm mentioning here, obviously this can be monitored by something like Nagios, but what I have in mind by mentioning here is more like watching it in the training software like Cacti. You can, see the graph, and it's very good to actually visualize the evolution of the use connections. And my experience is that as organizations grow a lot, sometimes there's not the best communications between the people, deploying new application servers or code changes and the people managing storage devices and database servers. And so I have seen at least a few times in which, new node app servers are deployed, and eventually, the database runs out of connections. And it's not a big problem if it wasn't for the fact that it generates errors on users and produces some downtime. But what I mean is by no big problem is that it will be just as simple as increasing max connections. It's not that the database is overloaded. It cannot put up with the load, nothing like that. It's all okay. It's just that there was some miscommunication between two different teams working on the same thing. And so by looking at Cacti and having something like Nagios or your software of choice monitor this, you can find out hopefully in advance and just go ahead and increase this if needed. For workload changes too, is very good. For example, training software will let you know a lot of things like temporary tables that have been created, those that have been created on disk, the ratio of the different type of handler invocations, like insert, delete, find by key, find the next in random order, things like that. And to a point where anybody working regularly with the system learns to get a feel for what's normal there, And so you can then see rather quickly if, for example, there is a spike or an increase in temporary tables or in full table scans. And this is very good because maybe you watch it before it's a real problem. Code is deployed, say say on Thursday, and the actual problem starts Friday evening because your website is such that users tend to use it on weekends more. So if you know this in advance, you can go ahead and change the application or take some other precaution measures before it's too late. So even if you did the proper testing that I mentioned before, some things may always slip, and it's good to have this in mind. And so finally, indispensable for me as a consultant working with emergencies, but also for you when you're dealing with your own servers, having something like training software provides a normal baseline that you can compare when investigating an emergency. It's very useful for me. I cannot stress this often enough because a lot of times people, even if they are very involved with their software and their stack, they don't really know well the answer to questions like, how many users are normal for you? Or, how many query per seconds are normal? How many writes? What's the read-write ratio? And so if you have this online, I don't really need to ask. I just go and take a look. And I also, the other extra benefit is that this gives me something to compare my changes. I change something and then I can wait 2 minutes, 3 minutes, get this to refresh, and I can see if I'm making things go back to what they should look or not. So for all those reasons, it's very important to have monitor and trending software. So to sum this all up, I guess the message that I want to send is that failure will always be a part of life, including IT life, and sometimes you will even be hitting completely unpredictable problems. But if you put this recommendation in practice, you will be protecting yourself against a lot of causes of downtime. Some of the most common ones, like you saw from the earlier graph. I mean, almost 60% of the cases that I work on, and believe me, we work on a lot of cases in Procona that from customer emergencies, and 60% of them would have been avoided with these measures in place. And I guess probably because a lot of them sound obvious, is that maybe people never really get around to them. Having backups seems like the obvious things, but how many actually do it? How many do it at home? So much less at work. And so you should consider them, as best practices that even though, they should be widely deployed, I have seen them a lot of time not being there enough to merit talking about this to a wider audience. Also, one thing that you can do, because I'm not silly and I know that there are budget constraints involved too, so you cannot always have the best world where you back up everything and you have a redundant copy of every component and all that. But at least you know what you need. You can do the math and you can, show to yourself or a customer or a manager, okay, here's where we should be, here's where we can be because of what we can afford, say, and you can even put a specific scenarios in case, if, when it happened with the Amazon outages recently, if you can only afford to be in a single availability zone, that's it. It doesn't matter if you have two servers there. The two can go down at the same time. So maybe you're okay with that. It's just a risk that you're willing to take because you did the math and the cost benefit is erring on the side of just taking that risk. But it's much better to do this as a conscious choice with a solid background than just waiting for the problem to happen and not really knowing what. Well, thank you all for attending. That's my email there in case you have follow-up questions besides what Elisa may ask me now. And well, I'll be replying to them as soon as possible. Thanks again.
Thank you very, very much, Fernando. So everybody, if you have any questions for Fernando, please go ahead and enter them into the questions panel within the GoToWebinar control panel, and I'll read them. We'll take as much time as we have left, and those that aren't addressed, Fernando will address in a follow-up blog post on the MySQL Performance blog. Okay, Fernando, the first question is, how can we get an estimate of the downtime required to back up, replicate a MySQL server based on the size of tables in it?
Okay, well, basically, it will boil down to your I/O capacity. But first, it also depends on the storage engines you're using. For example, if you are only using InnoDB, you can take the backup and create a replica with no downtime at all. Well, actually, very little downtime. You just need some downtime to get bin load coordinates This, of course, assumes that you are running the server with binary login enabled. If not, you will need the downtime enough to restart the server to apply that change. So if you're only on InnoDB, the two most common options I can give you are MySQL dump with the --single -transaction option. This will give you a consistent backup and will not block anything. And the other option is extra backup. And if you go to the extra backup documentation, there is a section called, I believe, how-tos and recipes. And one of the recipes is precisely setting up a replication slave using extra backup. If you do have a mix of engines like InnoDB and MyISAM, then yeah, you will have some downtime. And basically what I would do is estimate the data set size of the blocking engines, say MyISAM, and then do an estimation of the I/O capacity of your drives. I normally don't trust manufacturers, so what I do is just go ahead and do a few DD tests, like copying large chunks of files, and I estimate from that. And that should give you an idea how long it will take to copy the files. And in MyISAM scales, you will have to be locking them while you copy. So that will give you a rough idea of the downtime that it will take.
Okay. The next question is, can I simply switch from SBR to RBR without problems?
Well, the answer is complex. First, it is supported. I mean, it's a dynamic variable, so you can just change it. In my experience, some workloads tend to have some issues with one of the formats in terms of locking. So I would encourage you to test a bit. This is specifically from row-based to statement-based. I have not experienced myself any problems with row-based in that regard, but with statement, depending on the transaction isolation level, you may have some problems there. But other than that, I mean, yeah, you can change. And to give you a quick example, one thing that row-based does not support is, well, at least in most cases does not support, is like online schema changes in a master-master scenario. When you have a master-master pair with only one active server and you want to do a change a table, and you do it on the passive node, and then you flip roles and let it replicate, and so basically you have very little downtime. That doesn't work in row-based in most cases because the event that it sends, it does not send the name of the columns, it just sends the position. So say, for example, if you drop a column, it will break. So what I have done in customers in that case is dynamically change to statement. Then we can do the change, the auto, let it all catch up, and when we're done, we switch back to row-based. So again, the final message is doable, and the variable is dynamic. You need to kill threads for them to pick it up, though, otherwise they will keep logging on the old value, at least in my experience. You may hit some inconvenience depending on your workload.
Okay, next question is, how do I mitigate max connection errors where host name cannot be found from a provided IP where there is none? And it says internal 10.x range.
Okay, I'm not sure I fully understood. So what I understand is you're hitting max connections, but you cannot track down the host from where this is happening, not even in process list. So that's a bit difficult. So normally what I do is there's two things here. First, if the server is actually like overloaded, and if you have rich max connections, but also MySQL is not able to put up with the load, in that case, there's no way other than actually starting to kill some connections. And so if you cannot easily identify them by IP, at least maybe you can do something like killing some read-only threads or killing the longest running ones. And there is a tool from the toolkit called ptkill that was designed for that, with that purpose in mind. If the server is not overloaded, it's just that you reached this limit. Sometimes it happens that people run with the default or things like that. You can just increase it. To fully the question. If you think that's not the case, feel free to send me an email and I'll elaborate a better response directly to you.
Okay, Fernando, I think that's it for questions today. Thank you everyone for participating in today's webinar. And as I said before, I will make sure that everyone gets a recording of this webinar with access to the slides within 24 hours. And with that said, thank you everyone and have a wonderful evening or day. Thank you again, Fernando.
Thank you everyone.